Hello again, Lightning Leaders, and welcome back to another exciting math video. I hope you enjoyed Mr. Horrigan's place value and subtraction reviews. Today, we're going to jump ahead in the packet. Word problems were the thing that was put next, and Mr. Horrigan and I feel that we should go over the operations of multiplication and division separately before we throw them into word problems. You'll do some division review with Mr. Horrigan tomorrow, and then the day after, you will get a word problem video from me. So with that said, in the packets, find the page that says multiplying a 3-digit number by a 1-digit number, and that is page 15. We're going to start with the hundreds, tens, and ones chart, move to partial products, and end with the standard algorithm. That's the way your parents know how to do it. Again, at this point in your mathematical careers, the goal is for you to find a strategy that works for you until you master the standard algorithm. Let's get going. If we look at page 15, it has us multiplying 500 by a number, 300 by a number, 400 by a number, and then it gets kind of nasty. Looking at this page, I think we should go down the right column. Let's go down the right side of the page. So we're going to start with 506 times 4. 506 times 4. Now, some of you do not need the place value chart. So if that is you, you can skip ahead to when I do partial products. But for this question, I am going to be using the place value chart. We're going to slowly be building our scaffolds up to the hardest strategy. So, if I'm using a place value chart, I know I need at least ones, tens, and hundreds. If I'm using my little chant here, I'm going to go with maybe th to be safe. So that is ones, tens, hundreds, thousands, and 10,000s. A little funny thing to chant as you're making your place value chart, and remember the order they go in. Now, we are starting with the number 506. So I need to write 500, so 0 in the tens, 6. And I told you in the addition video that we should really be focusing on tens frames. So I'm going to move that last one down there because that's a nice way to picture 6. Now we need to multiply by 4. And what that means is I need to have 4 copies of each of these in the place value chart. So I'm going to get a different color so that we can see that. So I need to make sure I have 4 copies of 500s. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's a lot of dots. I need to do the same for the ones place. I need 4 copies of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Notice how I kept them separated and I kept them in their own 10 frames. This really helps me make sure I'm drawing the right number of dots, and it helps me keep my work organized. Now, I have more than 10 dots in these place values, which means I need to do some bundling. So I'm going to start counting groups of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there's one group of 10. I'm going to count another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. There's another 10. I'm left with 4. So I have 4 in my ones place. 1, 2, 3, 4. Now I have 2 in my tens place. So there's a 2 here. All right, I have more than 10 in my hundreds place too. I gotta do some more bundling. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Move it over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have none left here. Because now that they've been moved, these are gone. And I have 2 in my thousands place. Which means that my answer, one number, 2 number, 3 number, comma goes here, is 2024. I can check my work over using the standard algorithm, which is what we're building towards. 6 times 4 is 24. Carry my 2. 4 times 0 is 0. Add in the 2. There's my 2. 5 times 4 is 20. 2024 is my answer. For the next question, we're going to be using partial products. So what I'm going to do is, on the left side of the board, we're going to have the partial products. On the right side of the board, we're going to have the standard algorithm so that you can see where this stuff is coming from. I'm going to erase this. If you need to see this any longer, just pause the video for as long as you need. Otherwise, we're going to move on to partial products. Okay. Continuing going down that right side of the page, we're looking at 298 times 2. 298 times 2. And I'm going to write it again on the other side of the board because we're going to keep track of the standard algorithm on this side and watch how it gets mapped from the partial products. Now, I know a lot of you like the partial products, and that's fine. The problem is going to become when we start getting to even bigger and bigger numbers, partial products is going to get super big, super fast. But for right now, it's going to work okay. If we take a look, partial products means that every time we multiply, it gets its own line underneath here. So let's look. 8 times 2, that is 16. This is 8 times 2, which is 16. And I'm going to write this over here to remind myself. Now, the next line is not 9 times 2. And this is the hardest part about the standard algorithm. I'm not standard algorithm, of the partial products, because you want to go, oh, that's 9 times 2. But where is this 9? This 9 is in the tens place, which means it's 90 times 2. It's 90 times 2, which equals 180. Because 9 times 2 is 18, and you multiplied by a 10, so you throw a 0 on the end. Our last number is not 2 times 2. This 2 is in the hundreds place, which means this is 200 times 2. 200 times 2, which equals 400. Now if I add them all up, 6 plus all those zeros is 6, 1 plus 8 is 9, and 4 plus 5 is 1. So our product, our answer to our multiplication question, is 596. Let's see if the same thing happens with the standard algorithm over here. I know that 8 times 2 is 16, so I put down my 6, I carry my 1. 2 times 9 is 18, plus 1 more is 19, I put down my 9, I carry my 1. 2 times 2 is 4, plus 1 is 5, I got the same answer. We're going to do one more together, and that's going to be 410 times 3. If you need to see this one more time, just rewind the video, or if you just want to look at it as an example as you continue to work through the worksheet, pause the video here. As always, the answers will be at the end of the video for you to check all of your work, and if you still have questions, reach out to your teacher and they will definitely be willing to help you. For this last example question, we are going to be looking at just the standard algorithm. Just the standard algorithm. So let's take a look here. 410 times 3. Now, just like when we add, just like when we subtract, we want to start on the right and make our way to the left. One place value at a time. Starting with 3 times 0. This is our first step. 3 times 0, which is 3. It's not 3. I don't know why I just said that. It's 0. It's been a long day. 0. Now, I'm going to switch colors so you can see where my steps are coming from. Next, I need to move my place value over. Next, I need to do 3 times 1. So this is my next step here. 3 times 1 is 3. And my 3 is going to go right here. And now I have one more step to do. 3 times 4. 3 times 4 is 12. My answer is 1,230. Now, these steps, these strategies, will work for pages 15 and 16. The only difference with page 16 is that it's 4 digits instead of 3. Let's actually do one 4-digit before I move on. Let's do one 4-digit just so we have an example. I'll do the same thing like I did last time with a partial product and a standard algorithm so you can see both and see how it's just the same even though there's one more digit. And I'll just do question 1 on page 16 right now. And that's 8,491 times 2. Let's start with our partial products. So each time we multiply, it's going to get its own line. And I'm going to use the different colors again so that you can really, really see this. 2 times 1 is 2. Next color. 2 times 9 is 18. But it's not a 9 because we're doing partial products. It's a 90. This is 2 times 90, which equals 180. Next color. 2 times 4, but it's not 4. It's 400. 2 times 400, which is going to equal 800. So that was our next step. Then we have one more step to go, and that is 2 times 8. 2 times 8, which this isn't an 8, it's an 8,000. This is 2 times 8,000, which is going to give us 16,000. If we add them all up, we get 16,982. Let's check it with our standard algorithm. 8,491 times 2. 2 times 1 is 2. 2 times 9 is 18. 2 times 4 is 8. Plus 1 is 9. And 2 times 8 is 16. Oh, we ended up with the same answers. Again, go ahead and try to figure out the rest of these problems. If you have any questions, reach out to your teacher. And in the next video, we'll talk about 2-digit by 2-digit multiplication.